two types of equations that are considered radical equations. So that's why there's 2 days on this. So all the equations today have like a square root symbol or they have a cube root symbol. I don't have any fourth roots. It's just square roots and cube roots in this. You might see a fourth root, but they all kind of get solved the same way. Why don't I have a pen? Okay, here we go. The first blank is just going to say a radical equation. And then it just tells you it's an equation that has a variable in the radicand. The radicand is literally like what's under the square root. So the variable is somewhere under a square root or a cube root or a third root. I just said cube root and third root, and those are the same thing. Fourth root, it's a radical with a variable underneath it somewhere, or a rational exponent. We're going to spend a completely separate day on rational exponents tomorrow. Okay, this is not hard. What you want to do, you want to get your square root, cube root, fourth root, whatever type of root you're working with, alone on one side. And then all you do to get rid of a root, and it depends on which type you are working with, is you're going to take both sides to a power. Okay, now what I mean by that, and I just wrote it like a general statement there, take both sides to a power. So if you are working with a square root, you are going to square both sides. If you are working with a cube root, you're going to take both sides to the third power. And a lot of times that's just a number. Sometimes it might be an expression, so we're just going to deal with a bunch of different types of equations today that deal with different scenarios here. So each one of these is just a little bit different. The main thing to remember, get the radical alone. You can't add or subtract things out of a radical. We have to get rid of the radical by either, if it's a square root, squaring both sides, cube root, cubing both sides. It's not hard to do, but again, you might want a calculator if you don't have one. Okay, the first goal, get the radical by itself. So in my lovely equation here, I have square root 5x plus 1. I need to get that by itself. Now, I've got a couple obstacles in the way there. I've got a minus 10 and I've got a 2 being multiplied by that square root. Does anybody know what should I do first if I'm trying to get that radical 5x plus 1? If I'm trying to get that alone, what would you do first? Yes, do not divide by the 2. So many people do that. You want to get rid of any addition or subtraction first. It's like order of operations backwards. So if I'm subtracting 10, get rid of that by adding 10 to both sides. You don't want to divide by that 2 first. Now, I'm going to end up with 2 times square root of 5x plus 1. 2 and 10 is going to give you 12. Okay. Now, how do I get rid of the 2 in front of that radical if I'm trying to get the radical alone? Divide. It's being multiplied. So it's not going to change the radical or anything. We're literally just going to get rid of that 2 divide. So I still have this 5x plus 1 under the square root, and that's equal to 6. Okay, now, do not I'm not going to subtract the 1 out of the square root or divide by 5. All that thing is under the square root, so you got to cancel out the square root. To do that, if it's a square root, you just reverse that by squaring it. Whatever you do to one side, you just have to do to the other. On the left there, all it's going to do, square root and squared cancel each other out. So you just copy 5x plus 1, whatever was under the radical side. The other side, you actually have to square the number. So 6 squared is 36. And then from there, this is just a couple steps for your equation. We're just going to subtract 1 and divide by 5. So if I subtract 1, I get 5x is equal to 35. Divide by 5. Bless you, and be done. Okay, you say that to me in a couple minutes. I didn't mean to scare you, but a couple of these are not quite this quick. All right, what should I do first on the next equation? Add 10 again, I guess. I wasn't very creative when I made these problems up. Okay, so now this one's a cube root. So cube root of 2x plus 1, add 10 to negative 5, we're going to get 5. Now, both sides, since I have a cube root, you just do both sides to the third power. All right, now, Again, don't add or subtract things out from underneath a radical. They are stuck under that radical. You got to cancel the radical out before you can move anything else. So this is just going to stay 2x plus 1. 5 to the third, 125. All right. Now, again, the 2 steps. I'm going to subtract 1. So I get 2x is 124. And then divide by 2. And x is 62. And you're done. That's it. Okay, now, each one of these, like I said, is a little different. The third equation I have here, I've got 6 plus 4 roots of x equals 50. What should I do first on this one? Subtract what? Subtract 6, bless you. Do not add that 6 and the 4 together. The most common mistake, I don't know why people do this, they just can't control themselves. They just had to add these numbers together and you can't. Do not add that 6 and that 4 together. I don't know why that is a thing, but it is. Get rid of the 6. It's to the side. The 4 is attached to the radical. Do not add those numbers together. Move the 6 by subtracting it. Then you have 4 times the square root of x equals 44. Okay, what should I do from there? Divide. Yeah, get rid of the 4. So you're multiplying 4 by the square root of x. Your whole goal, if you got a radical equation, get the radical by itself. So I want that square root of x by itself. So I got to get rid of the 4. Now, I get square root of x, and then 44 divided by 4 is 11. Now, this one's a little bit faster than the last 2 questions because I just have an x under the square root. So it's a square root, so we're going to square both sides. But then I will literally just be done with the problem because I don't have anything else to do. I just have a plain x here. So just square 11. Which is 11 times 11, so it should be 121. Is anybody having a question? Okay, now the next 2 at the bottom of the page look a little bit weird. So I have the radical in this case, in this 4th example. This is like by itself already, right? There's just a radical, just a square root. Again, you cannot add or subtract things out from underneath a square root. Sometimes people, like gut instinct, they'll just see that square root and squared and think that they can just write that as x. You can't do that. The square root symbol acts like parentheses. So do not just cancel that x squared out. You'd have to add it to the 3 first, and you can't do that there. So what you can do here is get rid of the radical. You already have the radical alone. This just is a little different than the last 2 questions. So I am going to square both sides here. All right? Square root and squared cancel each other out, so this is just going to be what's underneath your square root symbol. It's going to stay x squared plus 3. How do I do the right side of that equation if I'm going to square both sides? Yes, please don't distribute. Don't distribute. All right, you got x plus 1 times x plus 1. If you distribute that exponent to adding or subtracting, you don't get it correct because you completely miss out on the middle term. Anytime you square something or take something to the 3rd power, if there's adding or subtracting, you're going to have to make yourself a little FOIL box if you like a box. That's totally fine too. But I just call it a double distributive property. Got to multiply x by both of these guys. Got to multiply 1 by both of these guys. All right, so what do we get? We get x squared plus 1x plus another x. And then 1 times 1, don't write 2, should be 1. So this will be x squared. You got 2 x's there and a 1. Now I promise this is not bad. All right, do y'all see how we have x squared on both sides of that equation? Guess what? We don't have to deal with this. This is nice. If I try to get all my x squareds on one side, maybe I subtract it from both sides, it actually cancels out because you just have a single x squared on both sides of the equation. They're just going to eliminate each other. So really, I'm solving the equation 3 equals 2x plus 1. All right, so just literally 2 steps. I'm going to move the 1, so I'm going to subtract it since I'm adding it. So we get 2 equals 2x, and then I'm going to divide by 2. And 2 divided by 2 is just going to make x be 1. Anybody have a question? Okay. Now, this last one's probably the weirdest one. I have 2 separate square roots in this problem. So if you're trying to isolate a square root, I am literally going to add this -3 radical x minus 5. I'm going to literally add it to the other side. If you have two radicals in the problem, you want to get one on either side of the equation. So that's what I'm going to do here. So I'm going to add this 3 roots of x minus 5 to the other side. There is nothing we're going to do at this moment to get rid of that 3. You can't actually distribute anything as it's written there because it's outside of the square root. So I've isolated my radicals. I just happen to have one on either side. So I'm just going to do what we've been doing. We're going to square both sides to get rid of the square roots. Okay, now on the left, no big deal. Just square root and squared cancel each other out. So 4x minus 10. All right. Now, what do I do with the 3 on the other side of that equation? Yes, very good. All right, so I know this doesn't look like a normal product, but you have 3 times this radical. So this is actually that exponent property where you have a product to a power. So both of these things get squared. All right. Now, you don't have to write this out, but I'm going to write it on my. So this is then 3 squared, and then the square root of x minus 5 squared. That was a product. So this is going to be 4x minus 10. 3 squared is just 9. Now, the only thing you have to do here, you are taking this times this whole square root. The square root and square do cancel each other out, but you want to leave parentheses around that because you need to multiply both of those terms by 9. 9 is what I got when I squared the 3, so you just have to do a quick distributive property. So you got 4x minus 10. Now, just multiply both of those guys by 9. So you got 9x, 9 times 5 is 45 there. And then I'm just going to kind of do 2 steps in one real quick. If it's me, if I can, I like to try to keep my variable positive. So if it was me, I would subtract 4x from both sides. And I'm literally just going to do this in the same step because my handwriting's too big here. But I'm going to add 45 to the other side just in the same step real quick. So that way I'll have all my numbers on the left and all my variables on the right. If you take negative 10 and 45, you're going to get 35. And if you take 9x minus 4x, you're going to get 5x. And then I'm just going to divide by 5. So x is going to be 7 here. Okay, is anybody having a question about any of the equations on the front? All right. Now, the ones in the back, a little bit trickier. All right, now, I tried to do kind of, again, just different examples that you might run into. But there is a potential when you have a radical equation to introduce an extraneous solution. None of the questions we did on the front would have even had this as a potential. So, do you guys know what an extraneous solution is? Did we do this first semester, maybe with absolute values?
Yeah.
What, do you remember what it means?
I forgot that.
It's okay. Does anyone remember what it means? Extraneous? Very fancy math word for extra. And the word extra is literally in the name. Okay, so it's literally just like an extra answer. All right, so extraneous solutions, just in general, it's an extra answer that doesn't work in your original problem. You do all the algebra totally right, you didn't make any mistakes, anything like that, but there are certain math operations that can introduce this. Absolute value is one of them. What we're going to do here is we are potentially introducing an extraneous solution if you square something or if you take something to the 4th power. This is really only going to be something you're going to worry about if you're doing a square root or a 4th root. You can do this with cube roots and not have any problem, or a 5th root not have any problem, but you cannot have an even root equal to a negative number. So what you're going to be looking for here, square root cannot be equal to a negative number. I don't think I have any, but just in case, a 4th root cannot be equal to a negative number. Completely fine for a cube root. Like I could do cube root of -8, right? Cube root of -8 would be -2. I can do that. You cannot take a square root of a negative and get a negative answer here. So that's the only time you're going to worry about it. So these are all square roots on the back because these are the potential equations that could have a square root equal to a negative. Same rules apply. We're just going to get our square root by itself. So like in this first question, I'm just going to subtract 8. And I have radical 7x, radical by itself, equal to negative number. Not cool. So I immediately know right here, no solution to this problem. Because the square root cannot equal a negative number. I immediately know that. So if you see that on the homework and you're like, oh, square root equal to a negative, you're done. Okay, it has to be a negative number. It can't have an x with it. It can't be an expression. It has to be just square root, negative number, done. You can stop the problem. Okay, let's say you didn't notice that, and I'll just show you where the potential is to introduce this extraneous solution. If I kept solving this like we did on the front, I would square both sides. What happens when you do that is when I square that -6, this is what introduces the extra answer. Because when I square -6, it actually makes it positive 36. And this has a super weird answer if you continue to solve this. It's 36 over 7 there. But I'm just going to show this to you real quick. If you plug that back in, and I would always plug it back in where you have the radical by itself. If you plug that back in there, you'd have 7 times 36 over 7. And then that'd be equal to -6. If you actually do that, I know that looks garbagey, but actually the 7 and the denominator just cancel each other out. I get square root of 36 equals -6. If you do square root of 36 on your calculator, it's positive 6, right? That's the extra solution here. It does not work in the original problem. So this right here, this is not true. You cannot plug that in and get that equal to a negative number. If we had a negative in front of the square root, that's a different story. But if you have a square root by itself equal to a negative number, automatically no solution. So if you see any questions like that, if you notice that as you're going through, square root equal to a negative number, no solution. Okay. Now, the rest of these are a little bit weirder. So the rest of these, you're going to have a square root and it will be equal to an expression. So it's not a plain number on the other side. On this one, I have square root and it's equal to x. Anytime you're equal to a variable, you just do not, okay? In this question, I just know immediately x can't be negative. Because then I would have a square root equal to a negative number. So I just got to check that as I do my problem. Sorry. It just says can't be equal to a negative. I know right then and there that right side of that equation can't be a negative number. So here, if we get a negative value for x, we're done. That's not going to work. All right, your radical is by itself here. So we're just going to square both sides. What's going to happen there is I'm going to square x. All right, so I'm going to end up with 3x plus 10 equals x. All right, we'll throw back to first semester. How would you solve this? You got 3x plus 10 equals x squared. Okay. 90% of the people are rolling their eyes like, I don't want to do this. Do you guys remember how to solve quadratic for first semester at all? You can use the quadratic formula on this for sure. You just have to set it equal to 0 first. Okay, now, and I promise, any question I give you, you can use your quadratic formula on any quadratic equation. I promise, though, anything I give you is going to be factorable. If you want to try to factor, I think that can be faster. Period, you got to set it equal to 0 if you have a quadratic. If you want to factor, I would tell you keep the x squared term positive. It might be moving more stuff to do that, but if you want to try to factor, which I will not give you a problem that you can't factor in this section. So you can use the quadratic formula or you can factor, but I would set equal to 0 in a way that the x squared term is positive. So to do that for this problem, it's a little more work, but I would subtract the 3x and I would subtract the 10 to do that. So I'd get 0, and then you'd have x squared minus 3x minus 10. Okay, if you want to use quadratic formula, go for it. If you want to factor, that's what I want to see if you guys remember how to do this. I need to get the factors there. I got to have two numbers that multiply to get me -10, and the same two numbers got to add to get me -3. Close. negative 5, and positive 2. You said the actual answers to the question, which are going to be positive 5 and negative 2. It's what would set the parentheses equal to 0. So like if I have x minus 5, if I plug in 5, that would make it 0. X plus 2, if I plug in negative 2, that would make that 0. Okay, do what? I know that's what you meant. Okay, now here's the deal. Remember, if you have your radical and it's equal to a variable or an expression, you got to check to make sure your answer doesn't make that negative. All right, so if I plug in 5, we'd just be equal to 5, no problem. Okay, this would work. If I plug in negative 2, then I have a square root equal to negative 2. Can't have a square root equal to a negative number. So the answer here would be 5, and that negative 2 would be extraneous or extra. So, and you don't have to define that or anything, but I'm going to write it on my paper here. That negative 2 will not work in that problem, but the 5 will. So in this case, one answer works and one answer doesn't. Just got to check and make sure it doesn't make your square root equal to a negative, and you'll be good. Okay, let me try. I got 2 more here at the bottom. Okay, so this one is super similar to the one we just did. You have your square root by itself, and I'm going to square both sides to cancel that out. And I'm going to notice here I've got a square root equal to an expression. I know it's just an x, but I'm just going to write this for myself so I don't forget. X here can't be negative, because if it is, then I would have a square root equal to a negative number, and that's going to be an extraneous solution if that happens. Okay, now, like I said, super similar to the question we just did. Square root and squared cancel each other out, so I'm just going to copy down what was under the radical. Negative 5x minus 6 equals x squared. Okay, now here I've got an x squared and an x, so I got a quadratic. If you want to set it equal to 0, I would just recommend keep that x squared term positive. It makes it easier if you want to factor it. So I'm going to add 5x and I'm going to add 6 just in the same step to the other side of the equation. All right, now if you're into quadratic formula, please, please, please feel free. If you want to factor, I think sometimes that can be a little bit quicker than the quadratic formula. If you want to factor here, I just got to think of 2 numbers. When I multiply them, I get 6. Same 2 numbers, I add them, I would get 5. 3 and 2, not 5 and 1. So many people say 5 and 1. So 2 times 3 is 6. 2 plus 3 is 5. It has to fit both of those requirements. Now, what would my 2 actual answers be? Negative 2 and negative 3. Okay, now, here is the deal. You just got to check real quick. That 3 looks really bad. All right, so remember, if I plug it back into the original, you cannot have a square root equal to a negative. So if I put in the negative 2, we're going to have a radical equal to negative 2. No bueno, not good. Okay, now, same thing actually here, negative 3. Both of my answers were negative. Since that was just equal to x, neither one of these can work. We did all the algebra right, but it's just because we squared both sides. You got that potential for that solution that doesn't work. So this is going to be no solution. Neither one of our options worked there. So the question we just did, one worked and one didn't. This one, neither one of them worked. Okay. Now I'm going to do one more, and this one's probably the trickiest of all. I don't have the radical alone in this last question, so I do have to do one step real quick before I can square both sides, and that's going to be to move this 5 by adding it to the other side. Okay, now I have square root 3x plus 13 equals x plus 5. Now, this is a tiny bit different than the last couple questions because I just had those with a radical equal to x. This is where I would check. Once you got your radical alone, this is where I would check for extraneous solutions. So in this case, I have a square root equal to an expression here, not just a plain x, but an x plus 5. So here's what I would tell you. X plus 5 cannot be negative because I can't have a square root equal to a negative. In this case, it's that whole expression. So I'm going to plug it back in there when I get my answers to check, but I do not want whatever my x value is plus 5. If that's negative, then that's going to be a problem. If it's positive, we're going to be okay. As long as it's positive, we're good. Okay, so let me grab my highlighter here. All right, so I'm going to square both sides here. Now, this one's a little bit extra because we got a FOIL. So you got 3x plus 13, square root and squared cancel each other out. X plus 5 squared. Don't distribute that exponent because you will screw it up. Okay, so you got to do a FOIL. You cannot write x squared plus 25. That's not going to work. You'll miss the middle term. So just a little double distributive property. Draw yourself a box. Use the FOIL, whatever is your favorite. All right, so I'm going to do x times x. I got x squared. X times 5 is 5x. And then I got to multiply 5 by both of these guys. So I'm going to get another 5x. And then 5 times 5 is 25. So I've got 3x plus 13, x squared plus 10x plus 25. Again, I've got a quadratic here because I don't have an x squared on the other side or anything like that to cancel. So I would tell you set it equal to 0, but keep your squared term positive. So I'm going to leave the x squared where it's at. I would move this 3x, which is positive, and this 13, which is positive, by subtracting both of those. And I'm trying to set this equal to 0. So I get x squared plus 7x, and then 25 minus 13 is 12. Again, if you like the quadratic formula, please feel free, use your quadratic formula. If not, I promise, whatever equation, if you've done it correctly, will be factorable. I'm just going to see if you guys know. Can you think of two numbers, if you multiply them, you get 12, add them, get 7? 4 and 3. All right, so the factored form, one would be x plus 4, one would be x plus 3. Completely does not matter the order that you put those in. Your actual answers, though, is what sets those parentheses equal to 0. So this would just be -4 and -3. Okay, now this is different than the last two questions that we've done. So I got to check this. If I plug -4 into x plus 5, so -4 goes in place of the x, does -4 make that negative? No. Okay, if you plug it, -4 plus 5 is +1. As long as it's a positive number, you're golden. So this works. This is not a problem. It does not make that side of the equation negative. So as long as x plus 5 is not negative, we're good. So x plus 5 there, -4 plus 5, +1. Okay, if I plug in -3, does that make x plus 5 negative? No. Okay, -3 plus 5 is +2. As long as it's a positive number, you're golden. So actually, in this case, both of these work. So I actually have two answers to this last question. So these are all the different options I thought you guys could run into. So this one, both of them work. The last one, neither one of them worked. They were no solution. And then the first problem we did like this, one worked and one didn't. So you just got to make sure you don't have a square root equal to a negative. As long as you don't have that, you're good. Okay. Is anybody